Here are solutions to homework set number 10 for ECE 341. This homework set looks at testing with normal distributions. The first problem is here's data from Hector Airport. It's the monthly low for Fargo, North Dakota on each month, the mean and standard deviation. So given this data, what's the confidence at 80%, 99%, and 100% confidence interval for the low in November? Well, the mean and standard deviation come from the table. That's right here. For an 80% confidence interval, I go to a normal distribution and find out where is the tail 10%. Because if the right tail is 10%, the left tail is 10%, that leaves 80% in the middle, or the 80% confidence interval. The z-score for 10% tails is 1.28155. You can get that from a table or StatTrack. What that means is you go from the mean plus or minus 1.28155 standard deviations. So here's the standard deviation, there's the mean. Calculating, the low will be somewhere between minus 12.7 degrees Fahrenheit and plus 10.5 degrees Fahrenheit with a probability of 0.8. If I want to have the 99% confidence interval, I'm going to go to a normal table and find out for 5.5% tails. So left tail is 0.5%, the right tail is 0.5%, leaving 99% in the middle. How far right do I have to go from the mean in terms of standard deviations to get a tail of 0.5%? Turns out that distance is 2.5783 standard deviations. So going left and right, that many deviations from the mean, I get the low for November will be between minus 24.4 and plus 22.2 degrees Fahrenheit. Probability 0.99. Part C is a trick question. If I want to be 100% certain, then the z-score is infinity, which means I go left and right of the mean by infinity standard deviations. So the 100% confidence interval is between minus infinity and plus infinity, guaranteed. Basically, 100% certainty is nonsense in statistics. Problem 2. If I look at January, here's the mean, standard deviation. What's the chance it's going to get colder than minus 40? So what is that I do is I take the mean, I've got minus 40. How far is minus 40 from the mean in standard deviations? That's your z-score. So take the difference over the standard deviation, I get minus 1.96 standard deviations. Using StatTrack or normal table, 1.96 standard deviations corresponds to a tail of 2.485%. So there's a 2.485% chance it'll be colder than minus 40 degrees Fahrenheit. And just for fun, if you want to plot it, here's what the normal distribution looks like. Here's minus 40. This tail is 2.485%. Problem 3. If I look at June, here's the average high and the standard deviation. What's the chance it'll break 100? So again, what you do is here's the mean, here's 100. How far is 100 from the mean in terms of standard deviations? And then I can find out this area right here. Well, to do that, the distance of 100 from the mean in terms of standard deviations, that's the z-score, it is 1.76 standard deviations away. Going to StatTrack or normal table, converting this to a probability, the tail is 3.889%. So that's the chance it'll break 100 this coming June. Problem 4. What's the chance that June is going to be warmer than July? That's testing with two populations. Now, on average, July is warmer than June, but it's a normal distribution. So here's the PDF for July. Here's the PDF for June. There is a chance it'll be a warm June and a cold July. What is that probability? Well, the trick is to form a new variable called W. W is the difference between June and July. June and July are normal distribution. W has a normal distribution. The mean of W is the difference in the two. The variance of W is the sum of the two. Take the square root to get the standard deviation. So this is what W looks like. It's got a normal distribution. The mean is at minus 2.6. And here's 0. To the right of 0 is where June is warmer than July. What's this area? Well, to find that, I find the z-score. How far is 0 from the mean in terms of standard deviations? So 0 is 0.432 standard deviations away. From StatTrack, the tail is 33%. So there's a 33% chance June will be warmer than July, 67% chance July is warmer than June. And here's what the two distributions look like. They're fairly close. It's almost 50-50. Problem 5. Suppose I have a bunch of data, and I don't know which one's which. Which one is March? Which one is April? Well, kind of the idea is March and April have a mean standard deviation. If you plot them, this is the PDF for March. Here's the PDF for April. What I'll do is I'll pick up a number. In this case, I took the average, or the midpoint between the means. Call that my threshold. Anything to the right, I call April. Anything to the left, I call March. And in that case, if my threshold is 3.5, all these I call March, all these I call April. Now, the chance of a false positive, if I call this a positive, this a negative, a false positive would be this area. It was really March, but I signed it to April. A false negative would be this area. It's really April, but I signed it to March. To determine that, I take, for false positive, how far is my threshold from the mean in terms of standard deviations? Find this area. So for false positive, I am 1.65 standard deviations away. The area is 4.8%. So this area is 4.8%. That's a false positive. A false negative is I'd go from here. How far is my threshold from the mean of April? In terms of standard deviations, it's 1.16. Find the area of the tail. The tail is 12.2%. And everyone's going to get a different answer. Depends where you draw the threshold. If I move this threshold right, I have more false negatives, but fewer false positives. Move it left, I have fewer false negatives, but more false positives. It's kind of a trade-off. I can't avoid it. Problem 7 looks at regression. If you go to Hector Airport, they've got the average temperature in Fargo since 1942. That's what it looks like. Take the month of August. Do a linear curve fit. Is August getting warmer or colder? So take the data, paste it in MATLAB, pull out August, set up the basis as year in 1, do a least squares curve fit, and that's what you get. So this says that year is minus 0.0018. I did that wrong. My estimated temperature is minus 0.0018 times year plus 72.61. That's my curve fit. If I plot the two together, here's what it looks like. The blue line is the actual average temperature in August since 1942. The curve fit is the red line. Now what this tells you is the slope is the trend. Kind of surprisingly, August is actually cooling off. The other months are actually warming, but August is actually slightly cooling. Over 80 years, August has gotten about 0.14 degree Fahrenheit cooler. Some reasons might be getting cloudier. Cloudier, cools you down a little bit. Whatever. That's what the data says. Number 8 is correlation. But look at May and June. If it's a hot May, it's going to be hot June. Well, I can determine that. Here's my data. Pull out the data for May, June, coming up December. The covariance between May and June is 2.7. The correlation coefficient is 0.23. So there's a 23% correlation between the temperature in May and June, meaning if it's a hot May, it's more likely that June will also be hot. 23% more likely. If I compare May versus December, 6 months away, here's the covariance, there's a correlation. There's actually a negative correlation between May and December. It's not very strong, but it is negative, which kind of says a hot May implies a slightly higher chance that December will be cold. So that is homework set number 10 for ECE 341, Random Processes.